All right, now that we know that division is exactly the same as multiplying by a reciprocal, I just want to do some of these problems, and not to get the answer, but to understand how to see the factors in a division. Okay, so like divide the following factors. Well, I know the answer to this, 30 divided by 5. I know the answer to this is 6. But if we look at the factors, we need to treat the division by 5 as a factor. And what we call it is a fractional factor. So the factors of this term are 30. The division by 5 is the same as a factor of 1/5. So the factors that are involved in this expression are 30 and 1/5. Now we could rewrite this as 30 over 5 and use the fraction bar to separate those factors like we did up here. So again, we have an expression with division. We need to treat this division as a factor. So we're going to invert that, or take the reciprocal, right? And this factor would now be a factor of 7. Well, 7 over 1, but it's the same as 7. So the factors involved with B are -2 and 7. Now again, I don't want us to worry about getting answers. I just want us to be able to treat these as factors and understand how to recognize the factors when I have division. Again, here I have it divided, and now this fraction, right, the divided by 5/3 is the same as a factor of 3/5. So this would be 2/7 times 3/5. Now again, we could split these into our factors like we did before. Say this is the same as a factor of 2 and a factor of 3 in the numerator, and a factor of 7 and a factor of 5 in the numerator, or in the denominator, I'm sorry. So once we understand the factors, then we can, obviously we can go through and then write our answers. -2 times 7 is -14. And then 2/3 times 7/5, we just multiply across the top. We would have 6 over 7 times 5 is 35. But again, we want to go through and look at composition and see all the factors. So a fractional term has a fraction bar as a grouping symbol. So this is kind of new. The fraction bar again acts as a grouping symbol, and it separates the numerator, the factors in the numerator, and the factors in the denominator. So when we see a fractional term, I want us to be able to identify the factors. So one fraction like this is a -2/3. The factors, well, the negative outside of this grouping symbol is like a factor of -1, and we can always treat it like that. The 2 in the numerator is a factor of 2, and the 3 in the denominator would be a fractional factor of 1/3. So again, these are the separate factors. We can write our fractions either way, but again, we want to be able to work with individual factors. Now, the nice thing about -2/3 is if you think about these factors, then we can group these factors in any order. Sometimes you might see -2/3 as -2 over 3. And the factors here would be -2 and 1/3. And you notice what that is just -1 times 2. I'm just grouping these factors together and keeping it as a factor of -2. This is not very common, but you might see it as 2 over negative 3. And the factors would be a 2 in the numerator, right? Factor of 2. And the negative 3 in the denominator would be a 1 over, or a negative 1/3. And what that does is it groups the negative 1 and 1/3 together as a factor of negative 1/3. So the negative 3 in the denominator is the same as that fractional factor of negative 1/3. So again, it doesn't matter how you put the factors together. Just realize that we could split this up into 3 factors, negative 1, 2, and 1/3. So what happens if we have a fractional expression where we have more than one factor in the numerator and denominator? Well, again, we treat each factor individually. So the 5 times x in the numerator would be a factor of 5 and a factor of x. The 13 times y, the 13 in the denominator is a factor of 1/3, 1 over 13, and the y would be a 1 over y because they're in the denominator, or fractional factors. So again, I'm not telling you right now that what to do with this. I'm just reading the composition, reading the expression, the fractional term as factors. Now here we have a division. So before we can look at the individual factors, we need to invert and multiply. Change this factor to a factor of 3 over 2. So the negative 1 is a factor of negative 1. 3/5 would be a factor of 3 and a factor of 1/5. And then the division, this factor here, would be an inverted factor of 3 halves. And we could break the 3 halves up into 3 and 1/2, but we could group these factors any way we want. And that's the beauty of composition, is that when I look at expressions, I don't have to look at it from left to right. I can group these factors any way I'd like. So one way we could look at this too is that the negative 1 we could leave out as a negative 1 factor. The 3/5 we could treat as a fractional factor, this 3 over 5. And then the 3 halves we could look at as a factor too. So you could group the factors together and look at those as fractions or individual, like we did before. So what if we have something like 2/7 divided by x? Well, again, when I have divided by, I need to invert. Well, x is the same as x over 1, right? And if I invert that, then this would be the same as a factor of 1 over x. So I have a factor of 2/7, or 2 and 1/7, and then a factor of 1 over x. Now, if you think about this, isn't that the same as 2 over 7x? And the x factor, again, if we put this together as one term, the x factor, the divided by x, is a factor in the denominator. So when we have a fraction bar like 2x over x plus 2, we have to realize that it does act as a grouping symbol. And the grouping symbol, remember, basically groups the whole top and the whole bottom. So basically we could take a fraction bar and put parentheses around the numerator and denominator and treat them as a fraction, because parentheses represent fractions. So when I look at the individual factors of this, well, the numerator has factors of 2 and x. They're both 2 or multiplication, so I could take those factors and split those up into 2 like that. But the denominator, you notice, is terms. This is 2 terms. So this is a grouped factor, and I have to keep it as a grouped factor. I can't split those up because they're 2 separate terms. So the grouped factor would be a 1 over this x plus 2. So I can't split those 2 up because they're 2 terms. So I treat it as one factor itself, as a group factor. So the reason why we do that is if I had grouping symbols in an expression like this, think about if I have divided by, and this is a group factor, well, the division treats that factor as a 1 over the 7 minus 12. And I'm not going to evaluate it yet. The other factor is just 5. But isn't that the same as 5 over, and then the fraction bar groups the 7 and the negative 12, or 7 and negative 12. So again, it's a way to write expressions cleaner. I don't need extra grouping symbols. Like I said, if you don't understand the grouping symbols of a fraction bar, there's no reason why you can't, when you see a fraction bar, is just take and surround the whole denominator and the whole numerator with parentheses. And that'll just help remind you that these are grouping 2 factors.